Alright, time for another draftphysics.com, debatephysics.com also. Video presentation. I gotta fix that. Yeah, we don't need him here. We'll put it way over here or something. Anyway, alright, so just another response video to something that shouldn't have to be debated among reasonable people. I would argue that there's just tons of evidence that momentum does do work in the universe. Lots of cases, spaceships for example, clear example where momentum does all the work. Kinetic energy is a waste of time to even consider because it will have nothing to do with your motion. So if I throw something and I give it kinetic energy, well, I'm also giving it momentum. There'll be two numbers. The kinetic energy number will be this big giant number. The momentum number will be this much smaller number. The number I get as motion in the opposite direction, as work done on me, will be the momentum number every single time. Okay, so, I mean, things like that are just glaring, decisive pieces of evidence that this whole idea that there is some notion of an mv squared somewhere, that it's necessary to understand that things have some sort of spiritual innate energy hidden from us, that their actual motion is not their energy, whether they're spinning or moving linearly, that somehow there's other energy that we can't see, that we must presume to exist, and that small things going fast have magnitudes more energy than slow things being big. Yeah, that's it. Big things going slow. Anyway, it's just so bad. So these clowns keep making these videos saying they're proving, okay? So even though we've seen Bruce Yearney crash cars, no evidence. We've seen the oscillating levers, no evidence of kinetic energy being any part of the calculation, any part of the physics at all, the dynamics. Mythbusters crash some cars. Well, let's all ignore that. So it's just in the face of the fact that they have zero physical evidence, in the sense that science has never tested any of this stuff. They never dropped 4 pounds 1 foot and 1 pound 4 feet and proved that they're the same impact energy, even though they're not the same momentum. So these were the numbers from his latest experiment, and they just don't make any sense, right? So so the part that makes sense is one mass going 1v has a number. You'd argue that, okay, if I take that one mass and move it twice as fast, it should be twice as much energy, and it is. In terms of this number, it's twice as big a number, but it's 4 times the kinetic energy. So even though it's only twice the impact of the rubber band in this case, it's supposed to be 4 times the energy, which, well, that doesn't make any sense. It's twice. Twice is 2.6, yeah, 5.0, yeah, very close. And then they do the 2 mass going 1 velocity and get this idiotic 3.16 number. Okay, so that's a 2 kinetic energy. So 2 Ke, all right, so 2 Ke is, you could make twice the kinetic energy by just taking a 2 mass and going 1 velocity. And so if you did say, well, how do I make 4 Ke? Well, if I take 2 of these Kes, that is, I take 2 of these experiments where, it's only 2 Ke, I'll end up with 7.2. Okay, so so I will greatly increase the capacity to make this 5, so I can make free kinetic energy, obviously. It doesn't add up. It doesn't make any sense. And they're basically saying that if I have one football player going 1 speed and he crashes into some guy, that if I have 2 of them going the same speed crash into the guy, it won't be twice the force. It's only 3.6. It's a lame 60% of the force, of twice the force. It's only this 1.4 thing somehow, and it's not this. It's obvious bullshit. Okay, so they want me to keep explaining why the flaws in their dopey experiment. So this is an image I created in the last video, and I didn't even notice things about it. So Dispar said that this gigantic difference in the parallax, or whatever you want to call it, the way the ruler is seeing the world, and it is gigantic. So if we just go by this little rod here that's holding the rubber band, I mean, it's 16.5, almost 16.4 here, and it's 15.8 over here. So that's a difference of at least 6 millimeters, and he's calling that 2 millimeters. So it's this whole thing, So there's so many things wrong, okay, with the whole theory of this. So first he has these rubber bands bound together somehow in this newer experiment, and so who knows what that does. Who knows what rubber bands are any good? They don't make scales out of rubber bands, frankly. Okay, I mean, that would be nice and cheap, right? If you could make a scale out of rubber bands, and you, yeah. So obviously rubber bands get hotter the faster you expand them. They do a lot of things. So maybe they're not even good scales. That they'll always, give latitude to velocity. That is, things going faster will be easier to affect the rubber band, because the rubber band degrades in its function because of that heat. Also, this is all being done on an arc. Well, there's no point in me making any gestures, but I guess I could use the thing. So when these things swing, they're swinging on an arc. So that's obviously, the rubber band isn't being expanded perfectly linearly. Now, both of them are supposed to be basically going to arc the same distance, so it probably shouldn't make any difference, but again, who knows? Now, the key factor, the thing I hadn't noticed until I went through a few of these clips, and I said, wait a minute, is this turning thing. Oh, what the hell was that image? Well, we won't worry about that now. So if you look at this one, goes in nice and straight. So the mass without the one mass is this hollow one. The two mass is this one. Every single case, the two mass is turning to the left. Well, it's turning to the right from its directional. But anyway, it's turning, it's twisting. All right. So, I mean, that's a huge, what the hell is that coming from? Because the only way it could turn is that it has to use the gravitational energy you're giving it. So let's understand the experiment is just simply you're supposed to be getting these distances right, which we can't really see in any of his experiments whether he has these distances right, the 4 times the height. But anyway, you're dropping it and letting it swing, hit the rubber band, and expand the rubber band. So again, the rubber band's on an arc. Okay, so that's not perfect. It's swinging on an arc, so the rubber band's stretching non-linearly. But anyway, so the object is sitting here like this. Now, if I rotate it, right, he just holds it and then lets it go. Now, if these are rotating each time, well, that rotational energy can't be being created by anything other than gravity. The very gravity that's going to be pushing this down, which is the same as pushing it this way. So if it's turning, it's obviously any energy used to turn it is energy lost to the linear motion. You can't do this much of this if you have to do some of this. So as soon as you do some of this, you're going to lose some of that. I mean, it's that obvious. So I didn't notice it, but I mean, that's a huge defect. Why is each one of the heavy masses turning? As it's going in, it's turning. Each experiment, every single time. So, yeah, I'd say that might be a reason why these numbers are obviously crap. Okay, so, all right, so let's just go. I'm just going to keep doing this. I'll just keep going over all the experimental evidence. So again, they're saying the 2 football player thing doesn't happen. And again, as I just pointed out with, Bruce Yearney did the experiment, okay? I mean, he did the contest between the 2 mass, okay, and the 1 mass, and having the same momentums, okay, and obviously very different kinetic energies. And the fact is momentum again decides, because the collision doesn't move. The collision happens right here, both objects do blah, 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 blah. And there is no evidence that the one with twice the KE, which they're claiming here, that this has twice the kinetic energy because of this doubled velocity of twice. Well, anyway, that a 1 mass going 2v is not the same as a 2 mass going 1v. So they're saying that there's this difference. And the fact is, yeah, by kinetic energy, it's this difference. And look how these numbers really don't add up to that difference. I mean, it really just looks so funny to say 4 KE looks like 5 and 2 KE looks like 3.6. So it just doesn't, obviously doesn't make much sense. But that's what the whole quadratic thing causes, is this irregularity. Where, again, you can do this thing twice and make more KE. So you can put 2 KEs in, 2 KEs, and you'll end up with more than 4 KE in work. So I mean, but I'm just saying that Bruce, you already did the experiment. 2 KE doesn't win the collision. So it has twice the kinetic energy, and there's zero evidence that it wins. And then when you can make it 4 times the kinetic energy, and it still doesn't win. And then you can make it 8 times the kinetic energy, and it still doesn't win. Because kinetic energy is a fable. It doesn't do any work. And every single experiment proves it doesn't do any work. All right, so let's go through the experiments. So it does, frankly, shock and amaze me that in the 350 years that this garbage theory, has been proselytized, that, and very strongly in the last 150 years, as, just presumptive. We can't even say the word kinetic energy in terms of talking about active energy without them saying that means kinetic energy. That means mv squared. And, it's... you're just saying, how can it be that nobody, not a single scientist, could sit there and just think about again, scales at doctors' offices, all the different ways where you can just see the truth revealed. But the simple truth is, that a suspended balance, is telling you what equals what. And the distance is completely proportional to velocity. So that's the law of the lever, is really just the part about where the distance is multiplied times the mass, and that tells you these are the equalities. So a half mass, or 1 mass at twice the distance, is the same as a twice mass, at 1 distance. And it will oscillate perfectly. So if I inject a little bit of energy into it, it has no energy on its own, it will balance, perfectly. And it's going to balance when it's suspended above, because of a catch. Now if I suspend it from below, it'll only balance when it's perfect. When I get this exactly perfect, it'll balance, but any imperfections will be exaggerated, and it will tip and stay tipped. All right, but a balance will keep adjusting. So, and that's because it's being suspended from the top, which just basically means that more of the lever itself swings from one side to the other side of the center of mass. So you make more stick on one side. So the more something goes up, the more stick it creates on that side, making that side heavy, so it has to go back down. So that's why it's a balance. So these two things themselves don't do anything. So if I balance it dead center of the lever, it will stay in any position. I can put it almost in any position, and the 1 mass and the 2 mass will not make it move. They'll just say, I don't care, the masses are compensating for each other, so nothing can happen, because the lever is no longer imbalanced. The lever stays balanced. And so it's just a huge giveaway. I mean, it's game over. I mean, this will, in fact, move 1 unit of distance, in a unit of time, All right, 1d and 1t. Okay, and this in fact will move 2 units of distance in 1 unit of time. Okay, this is twice the velocity. This is 1v. It's just plainly obvious, overtly saying, and it's so dirt simple, how could somebody argue with it? Now their claim is that somehow this is theoretically impossible for this to oscillate, because this can only go 1.4 the velocity, because then the kinetic energies would be equal. So this oscillator can't happen theoretically, and somehow you're cheating or doing something bizarre if you make this 2 mass. I don't want 2 here. This is 1v, okay, and this only goes 0.4 faster. So the mass that's half the mass only goes 0.4 faster for some reason. And the only reason why is they insist their theory says so. God, the Holy Ghost says so, therefore it must be true. Now that's how this series of videos with Steve Mould's name started happening, is merely because Steve Mould claims it and he didn't do the experiment. He didn't make this oscillator, because we know this oscillator won't work. We know if we have this at 1.4, okay, if we put the one mass at 1.4, it will not oscillate. This side will be heavier, this side will swing down, the end won't work, because the weights won't be the same. The masses won't be interpreted based on their velocities, okay, as the same weight. All right, so there will be no balance. So we know by that experiment overtly it can't be, and yet they claim this is what will happen, that if I actually make a device to launch things, okay, and I put a spring on here with a constant force, and then I pull this back a constant distance, and then I put a 1 mass on here, and I put a 2 mass here, and I do this test, to see that this will go 1v, okay, and they're going to claim that somehow this will only go 1.4. We'll do the experiment, because no, it doesn't happen. Now, Brozo already did the experiment, doesn't happen. I did the experiment, doesn't happen. The 1.4 thing, it just doesn't happen. Just a fact. And, so you're just saying, why is there an argument here? Why are people arguing this when you have to conserve momentum? They know that. They know everywhere, that's the whole Feynman block example, is you have to conserve these chunks of mass moving in the universe. You can't just pretend that because something is very tiny going fast, that somehow it has this astronomical capacity to do work, when there's absolutely zero evidence. So that gets to the ballistic pendulum experiments. I mean, every single experiment without exception proves kinetic energy a fallacy. Every single time you use a ballistic pendulum, you're stuck realizing that the only thing that does any work is momentum. And the only thing conserved is the momentum. And yet, I have to just keep doing this over and over. Alright, so really basic experiment, testing the capacity of something to do whatever this concept of work is. It is the right color. Anyway, okay, so ballistic pendulum. So this is a very credible scientific experiment done zillions of times, and frankly, it's a test. You're testing to see how much work something can do on an object. So I have an object, and I'm going to try to convert the energy from one thing into another thing. So I put a projectile and I shoot it at a velocity. So I have a mass and a velocity. And the simple argument is yes, the KE numbers, like I said, if there was, like for a bullet, for example, you're going to have a huge difference. Like momentum will say 2 joules of energy, and kinetic energy will say 2,000 joules of energy based on the squared velocity. And momentum will just say 2 joules. Or let's just for the sake of argument, for the sake of argument, we'll just say 2 joules. So that's what momentum will say, 2 joules. It doesn't see any of this this whatever this is, this Holy Ghost energy. And what happens when you do the experiment? Every single time, what happens? Well, most of the momentum, the faster the projectile, obviously some of the energy is going to get lost because you're converting a very high velocity into a very low velocity. But at slower speeds, you're going to conserve 99 percent of the momentum, and you're going to lose some substantial portion of the kinetic energy. Now, if I made this half the mass, I would lose half the kinetic energy. If I made it 4 times the mass, this is 4 times lighter, 1/4 of the mass, then I would lose 4 times. It just keeps going up and up and up. And in the case of the bullet, okay, in this case here, I'll lose 99. Oh, I wanted to do that in red. Yeah, 0.94% of the KE will not be doing any useful work. That's the definition of what kinetic energy is supposed to be, is this substance that does useful work. Obviously, it doesn't do useful work. It doesn't do work ever. So again, in the space analogy, if I did this in space, the same outcome. I can't possibly ever convert the energy that something's supposed to have, the kinetic energy, like say I bang into a particle with my spaceship. The physicist will say, if I make the particle have the velocity, well, that's the whole catch, right? Which one has the velocity? That somehow, because of that v squared, I got this huge, incredible amount of energy, and yet it won't be realized. It won't actually happen. It won't blow up the ship. All this stuff that should happen won't happen because none of these joules of energy are real. None of this is in the real, is anywhere. It doesn't exist. It's a fable. That's why it can't move. The KE can't move, be collected. So let's just understand that every single time the experiment's done, without exception, just the momentum is conserved. So just this 2 joules shows up over here, okay? And not even one more percent than that. You never have more momentum, not even a tiny shred more. And obviously in cases where you have a very fast projectile, you need a lot more to show up. But just, you're saying the difference between 2 and 2,000, and they can't even make 2.5 show up here. They can't make 3. They can't increase this percentage. They can't make 98% of the kinetic energy disappear. They can never get even one tiny little bit more, okay, than just the momentum. Clearly indicating there's just no hope for this silly theory that there's some sort of special energy involved here besides the fact that it's just masses moving, and that's energy in the universe, a mass moving a velocity. And there's always the same amount of that in the universe all the time, and all it does is move from place to place to place to place to place to place. So for us, the energy dilemma is we have energy in a big giant thing moving, and then we spread it into a bunch of tiny things moving in all kinds of directions, and so it becomes less useful to us. We can't use a laser beam that spreads, but we can use one that's pinpoint. So, I mean, it's just that obvious an argument that, yes, the energy becomes diluted. There's probably a better word. Spread, there's a better word for it. Dissipated. Yeah, and yes, it's less useful when it's going in all kinds of places in tiny discrete amounts, because we don't have any way to collect that and make that back into a straight line again. That's the hard part. There's no funnel to catch it with and have it all come out the way we want it. So anyway, but that's all there is there, and that's just a human dilemma. It's human purposes. But the real energy is always in this idea of thermodynamics. It's a real subject in physics. They know what the word is. And clearly the thermodynamics is unyielding. And the thermodynamics is just about masses moving, little tiny ones, big giant ones. And it's always just momentum. And I can't believe you're all so goddamn belligerently stupid that you won't concede. The evidence is overwhelming. All right, moving on. All right, suppose I should put in here, because it sort of is necessary for context, how did physics screw this up so badly? And one of the reasons is they don't really think about how a spring works. And the fact is, they do kind of know this, but they just kind of forget it when they need to know it. So, like, if I asked a physicist, well, if I throw a tennis ball at a wall, do I get back what I threw? And they'll say, well, no, you might only get 75% back what you got. But that's all they do. They just do some vague idea that, no, you don't quite get back. But they don't explain why you don't get it back. They just say, oh, it's heat and deformation or something. Some kind of stuff happens and the spring doesn't work. But it doesn't work in a very specific way, which is the irony. And it so obviously works this way. So this is what screwed up physics. In the sense they do these little rickety experiments with these imperfect objects and then pretend they're ideal. And they're not anywhere close to ideal. So anyway, springs are really good at collecting energy. So the energy goes in and it's quite reliable. So you can use one as a scale. You put one mass on, it goes 1 unit of distance, 2 mass, 2 units, 3 masses, 3 units, it works. But it fails dismally when it's going to give it back, and for like the obvious reason. You're saying, well, why doesn't physicists know this? I mean, I shouldn't have to be the one to explain this to all of physics. They should have already well documented the fact that, well, the fact is that velocity matters when the object's being launched, because the spring, when it launches something, will not retain contact. So if I take a spring and I oscillate it, put stretch in it, and it oscillates, and it'll oscillate for a half an hour. So it loses so little energy. So they get this idea that, oh no, it goes back and forth and it's very efficient. Well, yeah, but it's not if I push something with the spring. So if I actually launch something with a spring, the fact is the spring itself, all of its mass and velocity, is real mass and velocity. And the fact is it has to go as fast as the object it's pushing. And the fact is, when the object leaves, well, let's say it goes 30 miles an hour, the spring in that case is still going 29. The spring doesn't push and then just stop. It doesn't go 30 miles an hour and I'm just going to stop now because I'm all out of energy. The spring doesn't do that, okay? It still has 29 velocity worth of energy. It still has a lot of energy still in it. And then if it was pushing something that was much heavier and going to move much slower, so it was only going to go 10, okay, then you can understand the spring's only going to be going 9. So it's the same exact spring, one spring going 29 versus a spring going 9. You could understand that, well, those two springs have different amounts of energy. One going only 9 miles an hour is going to have 3 times less the amount of energy stored in it. So obviously the heavier the thing you launch with the compression, so I could take any spring compression, and if I want to get the most energy out of it, I put the heaviest object it could possibly move in front of it. And then if I want to get the least amount of energy, I put a little grain of dust in front of it, and I'll get the least amount of energy out of the spring. It won't give, it'll only give a tiny percentage of the spring's energy to the little dust particle. So, I mean, 350 years of physics, all these physicists, all these Einstein, all these people, none of them thought about this and said, yeah, you really can't do an experiment with the expectation that the spring is fair, that it treats light things the same way it treats heavy things in pushing. Because clearly it doesn't. It's not even close. I mean, gigantic differences. 99% of the energy lost not going into the object versus 100% of the energy going into the object. Huge variation. Well, gee, that should be accounted for in experiments. And the fact that I have to explain this. There's no one else to explain it. Nobody else can concede, oh yeah, it's perfectly obvious that's a reality. Springs don't give energy evenly. There should be a statement somewhere in the annals of physics that springs don't give their energy back evenly to irregardless of mass. And that statement isn't in AI, it isn't in physics somewhere, it isn't anywhere except in this video watched by 56 people. That's how deaf and dumb the science is that even if somebody else in the past did observe it and did state it, they didn't want to hear it. It's the simple truth. Because it does disqualify all their little rickety, silly experiments. It does point out how you really aren't being fair using your little plastic cart with your little metal wheels and hitting a 49-cent spring with it. That's really not an experiment of sufficient quality, okay, to draw conclusions from. So that's how we got here, is bullshit, cheap magic tricks. I mean, they're like the bouquet of flower thing. They're so cheap. You know, but, yeah, they're not real flowers. They're obviously all folded up pieces of paper. You know, I mean, it's such a cheap magician's trick, and that's all this bad science is just cheap tricks. Suppose I should have pointed out pulleys like levers, same rule, same distance rule. So the number of strings are basically a distance. They're just saying, so two strings, half the amount of distance this is going to move to the other side moving. So again, it's the same exact relationship, and it doesn't do this 1.4 thing. Okay, no evidence of it. I can move this at one speed, and this will move at twice the speed. Not this will happen, okay? 2x, 1x, always be in those proportions. Now, obviously, if I was doing this in gravity and I move this very, very fast, this could only fall at the rate of gravity. So, obviously, the rule isn't going to be in effect. So I have to have a constant force on things or a constant tension that allows them to move at the free speed. But I'm just saying that within the realm of the experiment conditions, it's just an absolute fact that the basic rule is if I have constant tension on these, that they have to move in this relationship. This has to move twice the distance in the same time that this moves if this string is taut. It can't go any other way. So as long as you keep the string taut, that's the only way it's ever going to come out. The 1.4 thing absolutely doesn't happen. So Steve Mould says this is real physics. This is the absolute truth, that it does in fact happen. And it doesn't in fact happen. Momentum is perfectly conserved. Kinetic energy is completely destroyed. The fact is this object will have 2x the kinetic energy that this one does in any force I put in. So it doesn't matter how I apply the force, this will always be twice the energy that this is. And it can't be, because the two sides are reflections of each other. There can't be any difference in them. One thing can't do something unless the other thing did the other half of it. And that's the way it is. The energy has to be conserved. And it's, it's insane that I have to make these arguments. It is insane. You're insanely, belligerently stupid. Oh, shit. So why am I talking to insanely, belligerently stupid people? Because there's nothing else I can do. I can't mind meld. Shake my finger vigorously. Yeah, none of that works. Alright, so let's do the thin ice rolling argument. Alright, and it's just so easy to understand that you can slide across, say, a thin section of ice. And if you go very slowly, that is, you just go very slowly across the ice, you will crash through the ice. And if you slide quickly across the ice, you will not break the ice. And the simple argument is the gravitational force is the same force. And the fact is it's time dependent. It is 9.8 meters per second per 1 second. Okay. So every 1 second you get this much force that is shooting out. So you could think of it as this illustration, as little BBs or paint spray. And you can understand that the faster you go, the less paint spray you're collecting, and therefore the less weight you can put on a surface. I mean, it's just so obviously, again, true. So you're just defeating gravity by going faster than the gravity can give you weight. Your mass takes time to have weight. It's just a fact. Okay. An absolute fact. A facty fact. A super duper fact. A double fact. A fact squared. Yeah, it's a fact squared. Okay. That it's a time dependent force. Okay. So this isn't, I really haven't seen that this argument's actually been used in the annals of physics. But you could take two objects, one with 1v and one with 2v. And you could argue that if I gave them, this one obviously got twice the energy, in their opinion, 4 times the energy. But anyway, and this curious thing happens when you roll things, okay, is that something with twice the velocity will actually go 4 times the distance. Now again, they have this rote thing in their Catholicism, their catechism. You have to learn these little mantras, and one of their mantras is distance is every distance. No, distance is poo. Now, obviously, if I did this experiment in space and I had a 2v object, it would go twice the distance in the same time, okay? So it wouldn't be 4 times the distance. So we know something else is happening here. And obviously what's happening is we're taking all the energy out. There's no constant force pushing. We gave them an impulse energy. The impulse energy runs out. And where does it run out to? Well, they'll all concede, Feynman included. It runs out to gravitational force applied to the ground, and now you've exchanged the motion. The linear motion of the object has been taken away. Its energy's been absorbed by the ground. And so in this case, what's obviously happening is as it's going very fast, it's not losing much, and then as it slows down, it loses more and more per unit of time. It gets heavier and heavier the slower it's rolling in terms of how its weight is being applied to the surface per inch. So in this entire section is 1 unit of time. This is 1 unit of time. Okay. Obviously this is 1 unit of time. This experiment is exactly the same as this experiment. The thing is rolling half its speed 3/4 of the way down the track. I mean, these are all indications that obviously the object's losing less energy to the ground the faster it's moving across the surface. And you could think about it rationally. Obviously on the Earth, that's always going to be true because the Earth is curved. Okay, so obviously the faster you go, you start defeating the curvature of the Earth. So if you go fast enough, you take off whether you like it or not. That's right. You can go fast enough and you'll in a straight line and you will go into space. If you go fast enough. It's just a fact. Because you're completely defeating the gravity pushing you towards the surface. You're going so much faster than it can apply its force to deflect your path into the Earth. So this is just obvious. So obviously this 4 times the distance thing doesn't mean anything because this ground only has twice the thermodynamic activity. The ground is only thermodynamically heated twice as much as that ground. That's the fact. And it's absolutely obvious and true. You can't claim, oh, it's 4 times the work because it went 4 times the distance. It doesn't mean anything. It wasn't doing the same amount of work per unit of distance. So obviously, distance doesn't mean anything. Oh, hell. Alright, so let's throw in one more argument. This is a real oldie and goodie. The bowling ball thing. Okay, so I have, unfortunately, well, it doesn't matter. Obviously I wanted to draw it more consistent with the argument. So this is the 16 pound. All right, so 16 mass, and it's only going to go 8V. And this is the 8 mass going 16V. All right, so obviously they say this one here has 2x the kinetic energy. So it has twice the capacity to do useful work. That's their argument. Okay. Obviously the momentum argument is no, not so much. And so you just have bowling pins here at the other end. Now, what's going to happen when these objects hit a pin is they're only going to transfer their momentum. They can't make the pins move with a total amount of momentum that's more. So even though it says twice the kinetic energy, it can't give it to the pins. It can only give the MV. The total momentums will be equal. The KEs won't be realized. So all you'll do is, obviously when you hit the first pin, the two balls hit the first pin, they'll do two different things. They'll give away a different percentage of their total energy. So exactly the opposite of the rolling argument. The fast object is going to give the pin, okay, a 16 velocity perhaps, 15 point something. And it's going to have its standard mass of, say, 3. And so obviously then when the 16 pound ball hits, it's only going 8V. So it's only going to be giving that first pin, 7, plus of velocity. This will make, well, I'm not going to change it now. And so obviously the momentums given to the pin will be higher for the kinetic energy, the higher kinetic energy ball. But the total number of pins it can give that to will be less. So over time, what'll just happen is you're gonna, the kinetic energy one will start off strong, okay, and it'll finish very weak, and the heavier ball will start off weak and get weaker, okay. But these two quantities, okay, the quantity where the blue one is higher, okay, then the red, this quantity will be exactly the same as that quantity. So where the red ball, the lighter ball, is giving away more, there'll be an inverse effect where the blue ball is going to give more over a longer period of time as the energies are extracted from the two balls. So they both lose their energy, and they're going to lose it at a different rate because of the difference in the velocity. The high velocity ball lose it quickly. The heavier ball will lose it durably. And it'll end up being exactly the same circumstance. So there will not be any total thermodynamic movement. Okay, the thermodynamic movement in both cases will be the same. There'll be a total amount of pin mass and pin motion. They'll both produce exactly the same. So once again, kinetic energy will decisively fail to show that it can do more work. It will be the same work. The pins will do exactly the same amount of thermodynamic energizing of the system. Okay. All right. So, I mean, it's everywhere. It's just so obvious. Momentum runs the universe. It runs on MV. That's the quantity always conserved, without exception, conserved. Well, almost without exception. I could talk about gravity. But anyway, I just... Can you see my pain? It's painful that I have to interact with organisms as dumb as you are displaying yourselves to be. I would almost... It would almost be it would probably be more tedious to talk to chimpanzees, but it's not that much more tedious. Because you have the language, you have the capacity to understand the sentences, you have the capacity to look at the arguments and be fair to them. Why are you failing to function as your neurology allows you to? You have the capacity not to be an asshole, a belligerent idiot. So why are you being belligerent idiots? Is this about some kind of God thing? Are you all just fake atheists who really believe in mysticism and woo, and you'll be terribly disappointed if this Holy Ghost energy isn't real? Why are you invested in this moronic nonsense, invented, by the way, by a complete religious psychotic? I mean, a fanatic nut. Why? Are you invested in this nonsense? Why do you need to show up and defend the great moronic theory? Oh, because conceding that physics makes mistakes? Oops, you can't do that, because then everything is on the table. All the little wooey quantum computing and your warp drives and all your space navigation crap and all your other bullshit that you want to believe in, your time machines. Fuck. So really, I might as well talk to Muslims. Yeah, forget it. This is just so bad. God, I hate this planet. But I will endeavor to persevere. The only rational choice.